Well, it's two things. As you saw in the video, there's point source and there's non-point source. For my side of the business in Hillsborough County, we're a point source. We have water treatment plants, we have wastewater treatment plants, and what we discharge is regulated by the EPA. They're now saying that we need to reduce the amount of nitrogen or nutrients in that wastewater stream. We use 60% of it in our reclaimed water systems, but what we continue to discharge into our streams, which is a smaller amount, we will be regulated and reduce from 3 milligrams per liter nitrogen down to 0.56 milligrams per liter, which is a tremendous drop. Now, we can do that with our sources because they're at one point. We have points along our system where we do this. The harder problem to crack is going to be the non-point source, where you look at every storm drain in a community. Those are non-point sources. And to clean up the entire Tampa Bay community, anything that drains to the bay, it's going to be a harder question to solve.
So the effluent from the storm drains is also going to be covered by these new EPA regulations?
Absolutely. What they're doing is setting the quality that the receiving body of water has to receive and has to become, so that wherever the water gets into that receiving body, it has to meet that regulation.
And how much of the water that we currently put into the storm system that ends up into the rivers and the bays, how much of that is actually treated right now before it ends up in there?
Treatment is an interesting question. The basic treatment that is done and permitted in subdivisions today is just capturing the first half inch of a rainfall event. Anything above a half inch can flow over the weirs and go on to the receiving bodies. So it's not, you can say it's a treatment in that if it's a smaller storm, and it's generally thought the first half inch of water carries the most pollutants. After that, the roads are washed off, things are washed off. Mm-hmm. So in the smaller events, it's all captured. But the bigger events, it washes.
So the bottom line is, it sounds like we have a tremendous infrastructure or treatment system that we've got to install as these EPA regulations take place.
Absolutely.
Okay. Well, interesting. There's a lot more to consider. Next, Carter is going to help us understand exactly what's in the water and who's responsible to make sure it's safe. Here's What's in the Water Anyway.
W.C. Fields famously said that he never drank water because fish live in it, like my buddy Bart here. Well, he's right about that. But fish aren't the only things in the water. Water is a great transportation system, and lots of things make their way to and through our water bodies. The key is to make sure that those things don't get into our bodies. In the United States, our water is so clean that WC can take a long draw out of the nearest tap and know it's clean and safe, no matter where he's at. That brings up a good point. What exactly is in our water? Where does it come from? And what do we do about it? One of the main culprits is heavy metal. No, not that kind of heavy metal. We usually think of heavy metal pollution as happening in industrial areas. You know, factories, plants, and mines. But cars are a significant source of heavy metal pollution. They are little pollution-making factories. Brakes release copper, tire wear releases zinc, and oil takes on metal as it moves through the engine and then leaks out onto the road. These metals attach themselves to the road surface and then are washed into storm drains and waterways by rain. Iron gets into our water from rusting cars and engine parts. My clunker's in here somewhere. That's just the beginning. Phosphorus and nitrogen, you know, the stuff that makes crops grow and landscaping lush, they are nutrients. And as it turns out, you can have too much of a good thing. When we overdo the nutrients, the next rainfall carries them into the storm drain and nearby water bodies. There, they encourage the water plants to overgrow. When that happens, the plants use up all the oxygen. It gives fish and other living things a bad attitude. I bet you'd be unhappy if we used up all the oxygen in the room you're in and there was none left for you. fish and other things that live in the water feel the same way. And as much as we love our lawns and food on our tables, it takes more than nutrients. It takes a little pesticide, too. And pesticides are poison. Because water is such a great transportation system, pesticides follow the nutrients into the water systems. Yum. Well, heck, we've met the polluters and it's us. Or the people who feed us or keep our iPods charged. But that's not all. There's stuff that just happens. For example, if your house has been around a while, like this one, it probably has rusty pipes or older storage tanks, or it could have a septic tank. Stuff gets into our water from both natural processes and from our own activities. So, you think W.C. Fields had a point? Only at the top of his head. But by the time water gets to our homes and businesses, it's clean and safe. It has to be. Someone is watching. So, who's watching the store here? Well, see those letters? That alphabet soup represents agencies or regulations that were created just to protect us and the environment. One of their most important assignments is to make sure our water is safe and clean. So let's see. The EPA is the Environmental Protection Agency. SWDA is the Safe Water Drinking Act. And OGWDW is the Office of Groundwater and Drinking Water. Can't believe I remember all that. And I wasn't even a good speller. There are limits on the types and amounts of contaminants in our water. They make sure the levels of contaminants do not pose any health risks. And science has gotten so smart that we can detect some of the smallest particles in the tiniest amounts, like finding a specific grain of sand in Ray J Stadium. Pull out your readers. Anyway, our drinking water is constantly tested. If the water supply standards aren't met, the water can't be used. I guess you could call the EPA the water police. I wonder if they carry water pistols. Oh, well, just asking. But it's not just about the feds. Every day in your community, people go to the water department and work hard to ensure that the water you get is the best. And they do that no matter what was in the water when they got it. For something that just falls out of the sky, water sure is a lot of trouble. Folks use it, adding stuff that wasn't there to begin with. Then folks clean it. And other folks check to make sure it's as clean as it needs to be. Everybody appreciates clean water. And by taking care of it for ourselves, we do better for everything else. What do you think, Bart? Let's go home. That's my boy.
So, Jorg, let me ask you this. Is it possible to clean up everything that's in our water, the pesticides, the nutrients, the oil that runs off from the autos, and all that stuff that we looked at in that video? Is it possible to clean that water once it's contaminated with all that stuff?
Well, with the technology we have today, absolutely. We can essentially clean or remove everything in the water down to the bare bone, which is H2O. But is that a healthy water you want to drink? Definitely not, actually. We have to put back in minerals to make it healthy and drinkable. So we can over-treat it, and we need to find the right level that we have a product that is fit for drinking.
That comparison to say that you could find a piece of pollution that's as small as a grain of sand inside the bowl of a football stadium is pretty amazing.